Hi everyone, it's me, Zoe. Today, I'm going to explain how you can program 3D graphics from the ground up. It starts with a point. This is the only place you'll call an OpenGL function, drawing a point at an XY value. And from a point, it's easy to create a line. You go through a loop, and at each step, you increase the X coordinate by 1, increase the Y coordinate by the slope of the line you want, and draw a new point. And with the ability to draw lines, you can draw a triangle. Draw a line for the left-hand side of the triangle, and record all the points you draw. Draw a line for the right-hand side of the triangle, and record those points. Then, for each left endpoint, draw a line to the right endpoint. Voila! Adding color is simple. Give the 3 corners of your triangles red, green, and blue values. As you draw the 3 edges of the triangle, change the red, green, and blue values slightly so that they start at the value of the start point and end at the value of the end point. Now you have blended edges. When you draw horizontal lines to fill in the triangle, they will blend between the border colors. You can also put images on your triangles by reading in RGB values from an image file. Consider a third axis, the z-axis. This axis goes into the screen, and the lower the z-coordinate of a point, the closer that point is to you. So this image would look like this in the depth buffer. Points with higher z-coordinates go behind points with lower z-coordinates. You only draw a point if its z-coordinate, that is, its depth coordinate, is the lowest depth coordinate at that xy value. With triangles, we can create any 3D object, like this cube. But how do we make these objects rotate? All we need is some matrix multiplication. Rotation matrices perform rotations to points. If we multiply each point in our object by a rotation matrix, we'll get a new version of that point, rotated about the x, y, or z-axis by a given angle, like so. Now we can create all kinds of complicated objects, and instead of writing out all the vertices yourself, you can read in vertices from an OBJ file, which contains all the coordinates of the vertices of an object and contains the faces of that object, which are just sets of 3 vertices. Next, we want to add lighting. We define a point as our light source, and for each point on our object, we calculate a unit vector in the direction of that light source. To obtain the lighting of each point, we take the dot product of that unit vector and the normal vector of the face that that point is on. The normal vector just means a vector that's perpendicular to the face. Often in graphics, we want to make an object appear rough or bumpy without going through the trouble of changing its geometry. For this, we can use a bump map. A bump map is like an image from which you read normal vectors instead of RGB values. You multiply the normal vectors that you get from the bump map by the normal vectors of your vertices, and there you go. You've created the illusion of texture. There's so much more you can do. My hope with this video is just to give you the idea that programming graphics yourself is really not that hard. Good luck and happy programming.